So thanks so much for having me here. I'm Piotr. This talk is called Ruby Smells, and after I created this talk, I realized that for me it's obvious that the smells are the noun here, and Ruby is just adjective. But in case you kind of misread it and assume that Ruby is the noun and smells is the verb, I'm not trying to say that Ruby smells as a language. Not at all. I think it's a great language, and I definitely, let me check one more. Yeah, I definitely don't believe that Ruby smells, not the language. There are some minor things that I really don't necessarily like, but there are pet peeves like, everything is public by default, which is not necessarily ideal, and everything is mutable by default, and like those two things, Rust gets really, really right. Everything is private and non-mutable by default. And my super personal pet peeve is that enumerable is returning arrays everywhere, and enumerable being my favorite Ruby module. It's a super minor thing, but if you have your own collection class and then you include enumerable, you have those wonderful enumerable methods, but they all return arrays, not your collection classes. So just pet peeves, but yeah, I'm not saying, sorry, I need to check one more thing. I'm not saying that your Ruby smells. I'm saying very technical conference. Very technical conference. Let me see here. Anyway, I'm not saying that your Ruby smells. Actually, let's see whether this works. Nothing ever works. Okay, I can do it one more. I can do actually. No, it's not a, sorry. It's just it's a internet thing, not. Is there another Wi-Fi? I could connect to. Onyx. Okay. Can you put in the password? I'm so sorry for this. So the thing about presentations, this is going to be a like semi-keynote, so I can talk about presentations. We still don't have like good tools for presentations, like at all. So I decided at some point that going with a web-based presentation system is the thing to do, but obviously it has its own words. So this is the slides I was hoping for. So thanks so much for inviting me here, and I always heard that RubyC is very technical conferences, and I heard very good things about it. So this is going to be a very technical talk. There are going to be a lot of code slides and a lot of code examples, but I don't consider myself a very funny person, so I kind of piggyback on other people's funniness. So there will be some quotes from other people. So as I said, I'm not saying that Ruby smells as a language. There are some minor bits. But the enumerable, as I said, is my most favorite part about the Ruby style library. And the first version of this talk actually has a grave mistake of not including a quote from Florian. So this is a version of this talk that includes a kind of self-referential quote from Florian. But the thing that I actually wanted to quote from him is this one: 2 easy steps to quickly get better at programming Ruby. Read about enumerable RB, read it again. So if you haven't dug into enumerable RB, please do. It's a wonderful module. It shows you how to implement modules in Ruby and how to get a lot of wonderful small things that can be used like every 10th project, but then like Partition that I will show you later that work really, really well. So am I saying that your Ruby smells? And yes, I do. And I also say my Ruby smells, and it's not necessarily a bad thing. And this is another thing that I really want to stress out. Not all code smells are bad. They are more of an indication that something could be potentially made better or actually looked into, but not necessarily that something is wrong. It's more of a, there are very, very good smelly cheeses, for example. So, and also, I've carefully trained myself out of the who wrote this crap reflex. Now I cheer and say, yeah, sometimes in the past, Yagnai triumph. Yagnai is, you ain't gonna need it. So also, don't refactor things for the sake of refactoring. Always refactor things for the sake of this getting you into a better place for the future. So again, there are very, very many cases where there's a piece of code that will never get changed. It works really well. It has been working for 5 years. I actually heard about a person who started using a tool that I'll be showing and started refactoring code that was running perfectly fine for 5 years, and it stopped because their factorings were not 100% compatible. So only refactor things when you actually think it will be beneficial. And yeah, let's start with the code examples. I have some caveats. All of the code examples use instance variables because this is the simplest way to denote state. So when you see an instance variable, you know that this bit of data belongs to the class. I personally prefer to use getters, but I will use instance variables for the sake of this code to make sure that you quickly recognize what is state and what is being passed into methods. But please don't cringe too much. I personally cringe at instance variables, but if you also have this reflex, just bear with the slides. Just assume that those instance variables are set in constructors or dependency injected, and those constructors are skips for simplicity. So without further ado, let's start to look at some code and see what I mean when I talk about Ruby smells. So there's a method on a conference class that is called navinfo. It takes a starting latitude and starting longitude, and it consults some other navigation source for the info from that starting latitude and longitude to the latitude and longitude of the conference. So those are instance variables. And first, it asks it for the distance, and then it asks it for the time, and then it repackages into a small hash that just gives you the space and time distance of this particular, for example, conference and somebody's home location. And the obvious thing that probably screams at some of you, at least by now, is that we are making exactly the same call with exactly the same parameters to exactly the same object. And especially in this particular setup, there is a chance that this is computationally costly. It can take time. It can take resources. This is not a good thing. We shouldn't do exactly the same call, especially if it's to some external service, for example, over HTTP. And this is obviously, but this is a simple code smell that I think we can all agree could be made better. This particular code smell is called duplicate method call, and it means that the same call was made more than once. And if you cringe saying that this is a really simple example and a really simple smell, I will try to kind of, step up my game and show you better smells. But the refactoring would be to just factor out into a single call. And still, even in this case, there's a caveat that there are cases, and I will show it to you, where the readability trumps not making separate method calls. So in this particular case, we can just create an info object that takes the info and then fetch the distance, fetch the time, and return it. We can actually simplify it now that it looks like this. And by the time we see this, we might figure out that maybe actually there should be 2h method on whatever this call returns that would make this hash or maybe a bigger hash, but that includes that information. So this refactoring not only hopefully makes our code better because it makes fewer calls to an external service, it actually leads us to potentially new API for a given object that could be beneficial in broader sense of the application. But as I said, there are cases where it's not necessarily a good idea to refactor. This is from my, so I work at the university, and this is from my, in one of my lives, and this is from my application that computes some kind of metric based on a circuit's inputs and outputs. And When they are both 0, then the metric, either of them is 0, then the metric is 0. If there are fewer than 5 or 5 inputs, then the metric is half of the outputs rounded up. And otherwise, it's the bigger number from half of the outputs and 1/5 of the inputs. In this case, this logic is super clear, at least to me. But there is a duplicate method call. Like this outputs slash 2.0 rounded up is made here and here. So we could refactor it like this. So half out, seal, right? So sealing of half of the outputs, and then use it here and here. But this is, in my opinion, a really bad refactoring. First, it's not really readable. Naming is super hard, as we will learn in a second. But also, in this particular case, it really doesn't make sense. None of those code paths are taken at the same time. This code will either go into this code path and return 0, or into this code path and call this once, or into this code path and also call this once. So there is really no case for this kind of refactoring. Another example is this code. There's a separation matrix, not getting into details. Just imagine an array of arrays where if you have zeros, it means the row and the column are not separated, whatever they represent. And if it's non-zero, then they are separated. So if we want to check whether a row and a column are separated, we check whether the row exists, because it's a sparse matrix, so we can kind of save some space if it's a all-zero table and just create an empty table, and then check whether the column contains non-zero value. This is technically a duplicate method call. The square brackets call on the matrix is made here and here. But to refactor this, we would have to do something like this. We would have to have something like this, call it. We don't really like shadowing variables, so we don't want to call row equals matrix of row. If we wanted to name this row, we would have to rename those like X and Y or I and J, which is usually less readable. And this return false could actually, like, should it return false? Should it return nil in this case? Like, what is it going, like, how should this behave? This code is pure from the code smell point of view, but this code, in my opinion, is so much better. It's also shorter, and as we all know, we should strive to write functions so small that you can fit a bug in them. Like, this code is so much easier to fit a bug in it. And, just don't refactor yourself out of, into a corner, basically. So let's go to another code smell. Let's say we not only have, like the navigation source can also return directions and distance and whether somebody needs a passport to go from one location to another. And in all of those cases, as you can see, we pass the starting latitude and starting longitude, and also the latitude and longitude of the conference. So in all of those cases, we pass exactly the same pair of values, and we have to strive to not mix them up, not flip them, not forget one of them. This is called DataClamp. If we pass the same set of variables over and over into many contexts, this is called the DataClamp, and the obvious refactoring is to create a composite object. It probably will be a simple value object, but that's a good refactoring. Still, there's also a caveat here. Make sure that the clamped variables are actually related. If you're passing a context and some kind of environment, maybe they're not necessarily so strongly related that you should make a object of them, or probably you're passing 3 variables of which 2 are very strongly related and 1 is not. So there are cases where even DataClamp is not necessarily to be refactored. And also, caveat, you can decompose them if when needed. So make sure, for example, in this case, where we are passing this to an external navigation source, if we don't have a thin wrapper that would explode our coordinates objects in this case, then we would have to be able to somehow explode them back into those variables. So we can do this. We can have a location struct that just has a latitude and longitude and start passing a location, like starting location and the current location. And if we need to, we can actually explode this struct. So Kiev is at those coordinates, and we can always, like, the struct has a, the way it works is if we splat it, if we explode it, then we can do it. And if you feel that this kind of code is a little bit hackish, like we are refactoring, so our code looks better, but then we still have to support the exploding thing. Just remember that if you ever code something that feels like a hack, but it works, just remember that the CPU is literally a rock that we tricked into thinking. Like, don't shy from pushing small hacks into places that you will refactor later if your main code can be made better out of it. And obviously, in this case, it basically, to me at least, it screams that this navigation source needs a thin wrapper that will do that, rather than calling some kind of external API directly. So let's go a little bit further. Let's consider a conference that we already have, but it's not necessarily the location is not yet set, or it's a conference that happens online and doesn't really have a location because it's a streaming conference. And in those cases, to make all of those calls, we'll actually have to check whether location is set, and this will be this same check every single time. This is called a repeated conditional, and it means that the same condition is checked in many, many places. And there are various refactoring to do it. One of them is to, for example, factor out a class that is called located conference that has a location and supports that method, and a unlocated or base conference class that doesn't have location and doesn't have those methods. This is not necessarily a good example in this case. Probably a better refactoring would be to make a navigation source that can work with null location. So, for example, your thin wrapper would basically handle a case where the location is somehow representing a location that doesn't exist yet. But that would be probably a better thing. But also, again, readability sometimes stops pure design. Don't refactor something in a way that the rest of your team will forever remember, not in a good way. Debugging is like being the detective in a crime movie where you're also the murderer. Like, don't make a very nice refactoring that it will cost you like 2 days of debugging, in a month's time. Let's go a little bit further. Let's say that we have a Ruby predicate that takes a parameter that happens to be a boolean flag, whether the check should be strict, whether the conference is considered to be strictly a Ruby conference where the only language mentioned is Ruby, and in generally Ruby conference when there are many other languages. Shout out to PolyConf in a month where there are very, very many languages, and Ruby is one of them. So we can query the conference whether it's a strictly Ruby or generally Ruby conference by calling this predicate and passing the flag. The problem here is it's a Boolean parameter. It's a flag that basically the caller directly controls callee's code execution. It knows exactly which code path this method of the callee will take. So it's not necessarily a good design because the caller knows exactly what the callee has to do. And the good refactoring would be, for example, splitting this into dedicated methods or dedicated classes. But also, caveat, consider caller usability. If it's a flag that you get from somewhere else, then checking the flag on the caller side and then calling the right method would be not much better. This could be, for example, a refactoring that we have a strictly Ruby predicate and a possibly Ruby predicate because the caller knows which of those methods it's supposed to call. But maybe the caller gets the flag from somewhere else, and in that case, it should just pass it on. And again, those are not necessarily good names. As I said, naming is a hard problem in computer science. It's NP stands for naming problem, for example, and NP hard means the problem is as hard as naming things, which is the hardest problem we know of. So don't please try to not refactor things in a way that they will be unreadable, but so much purer, and tools that find code smells will be so much happier with our code. Here we have a conference class that we can check whether it's successful. We pass it attendees collection. We partition the attendees collection whether we basically split the collection into attendees that are excited and attendees that are indifferent, and we check whether the excited attendees there's more of them than the indifferent ones. So in this case, we consider this conference successful. The problem with this code is it only works on the parameter. It doesn't refer to the instance state of the conference class at all. This is called the utility function, and it's a method that does not depend on instance states. It only operates on its parameters, and it could be moved anywhere into the system. You could move this method into the kernel module, and it would work just fine and be available everywhere. You could put it on string, and you could query the string, whether the string is successful, just passing it the same attendee collection. So the good refactoring would be to move it where it belongs. But it usually also means that we start realizing things like an array of attendees is not necessarily the object that represents the collection of attendees. We are just, we are just kind of reusing array to collect our attendees. And the caveat here is sometimes it's just a private helper, and or a helper method. And in this case, helper methods, in many cases, it's OK if they take parameters, because otherwise you would have to pass the thing you want to pass to the helper method through the state of the object and, for example, set it dynamically. So that could be a good refactoring. Just consider attendees to be a core part of the conference, obviously. So that would be one refactoring. And then, or maybe this would be a better refactoring. Have a attendees object that actually represents a collection of attendees that you can ask whether this collection of attendees is excited, and then have those attendees collection. In general, you shouldn't inherit from core classes, but for the sake of simplicity, let's do it here. And then we could just partition our collection of attendees and check the count. So this way, we push the logic from the conference class into attendees collection and actually check whether the attendees are excited. And this is also more readable and more object-oriented, at least in a way. Or you could do this, create a proper attendees collection, extend it with forwardable, delegate the partition call to the collection class, do something like this, have an initializer. I'm showing this as an example of, in my opinion, in this particular simple and contrived example, a little bit too much. So always when you try to be tempted into doing this kind of refactoring, yes, it's pure, it's very aesthetically pleasing, it's a super nice, just make sure that you won't have to, explain this to your teammates over and over again. I have a new metric for code quality, how much you feel the need to apologize for things when introducing a new team member to your code base. Like, I've been to code bases that are super pure engineeringly, and they take a month to figure out what actually those things do, because all of the classes are super small. Basically, there's no code of them. They just include tons of modules, for example, and that's another kind of worms. But let's say that conference is successful if either when we partition the attendees collection, not only whether they are excited, but maybe the language is Ruby and the attendees are Rubyists. And in this case, we actually query the language of the conference, so we no longer have a utility function. It no longer operates on the only attendees collection. It also checks the state of the conference, but it mostly operates on the attendees collection, right? There's an attendees call. There's a we iterate over it, so we basically go through the whole array, and then we check this count. This smell, it's no longer a utility function. We do check the state. We cannot move this away easily, but it's called a FeatureEnv. This is a case where the conference class is envious of the features of the attendee collection that it can get passed to. So it partially refers to instance state, but mostly to its arguments. And refactoring would be to move the code to one of the arguments with the caveat that makes sure that the knowledge is actually local to the problem. There are many cases where we have a very well-defined business process, and it's put all in one place. And there are a lot of cases where the business process refers to the arguments. And if we properly, kind of purely refactor it, so all of the code pieces go to the different arguments, you suddenly realize that your wonderful business process is now in 20 different files. And it's no longer easy to check what the business process actually does, because all of the details are all over the system and not in the one place they used to be. So don't necessarily do this. In this case, it would be, we would have to pass the language to the excited predicate, and then the excited predicate would have to check whether the given attendee is excited about the given language, and they are excited whether they are either inherently excited or they are a Rubyist and the language is Ruby. Like, this is, okay, this is in one way pure OOP. We are pushing the knowledge down to the smallest object that actually can work on a given, answering a given method call. But again, half of programming is knowing that you're doing something wrong but not being able to figure out what it is, and the other half is doing something wrong but not knowing it. So don't necessarily do this kind of refactoring and try to push it on your teammates saying that this is pure and this is how we should now do things. Always have this strong distance to your own work and try to figure out whether this work is actually universally useful and universally good or just subjectively good. And the last code smell I want to show is this one. We have a conference. This is basically a value object that has a city and a name. And we have attribute accessors, so both getters and setters for the city and the name. And this is called the attribute smell, where we basically, in general, setters are not necessarily a good thing in an OOP language, because this means that from outside of your class, somebody can manipulate your internals in a way that is outside of your control. If they can set your instance variables, then you can't even be sure what the state of your object is. You can't do any caching based on your object because somebody can switch the value of, or your caching has to be basically very clever and check the internals times and again. Whether getters are an attribute smell, it depends. There are cases, for example, in value objects where the getters are, in my opinion, perfectly fine. But if you have a class that has a lot of behavior and a lot of methods, then getters might also be not necessarily a good thing. A good refactoring would be to do tell, don't ask. So don't ask a class via a getter what's the status and then make method calls on it. Make a different method call on it that actually does the internal check by the class and then does something or not, for example. Or go with immutable objects that have a with method or an update method that could be called and gives you a different instance of the same object with just this one field change. I will show you in a second. And also, it might be an overkill in the simplest projects, but the simplest projects that actually end up working usually don't keep to be simple for very long. So, the simplest projects that we don't want to over-engineer sometimes, live long enough to be a big projects that would actually benefit for being architectured better from the start. So, for example, in this case, we can have only a reader, public readers, but then we can have a with method that takes a city and the name, and they default to the instance variable. This is how instance variable resolution works in Ruby. So you can actually use instance variables in the method signature, and it will work. And then you can have a polyconf last year that is in Poznań, and then this year it's in Paris. So you take the last year's polyconf and just say it's like last year, but with a city of Paris. And then the name just keeps, thanks to this default value for the keyword argument, the name keeps the same. There's a wonderful talk by James Coglan and Tom Stewart called Burn Your Getters. Here's Tom Stewart dressed as a Caesar, I guess, one of the Caesars. And I highly recommend watching this talk. It will show you that getters are not as crucial as we tend to think most of the time. So what are the real-world examples of code smells? Like, what projects could we look at and see whether there are, for example, huge functions that should be refactored? Of course, you can create super obscure gems that have this kind of issue, and like going through all the Ruby gems would be really unfair, but I just looked at the standard library, and there's a 433-line method in matrix eigenvalue decomposition that is called Hessenberg to real sure, and that's in your Ruby standard library, and there's this kind of method that has 433 lines, of which approximately 214 are statements. There's a rational test that is called testkumi that has almost 1,400, well, rounded up, 1,400 lines with approximately 700 statements. And there's this, my favorite, rdoc markdown _ C code method that I think it looks like it's auto-generated. I just really hope it's auto-generated, but still it has 1,600 lines, approximately of which 900 are statements. And this is in your standard library. This is the code that your Ruby might be using. And before we make fun of it, please don't criticize other people's code without also providing a example of how you would refactor it. Always be constructive in your criticism, and there's this quote, when you start a new programming job, you have to walk right up to the biggest function in the yard and refactor it in front of everyone. Like, don't criticize other people's code without trying to understand why it looks like this. It's not that people write bad code because they feel like it. It's usually there are reasons for the code to be smelly. So what are code smells? Code smell is a surface indication that usually corresponds to a deeper problem in the system. This is from the Martin Fowler's wiki, but the important part here is the second thing is that the smells don't always indicate a problem. Some long methods are just fine. You have to look deeper to see if there is an underlying problem there. Smells aren't inherently bad on their own. They are often an indicator of a problem rather than the problem themselves. Usually, if you have a code smell, it's not because this particular piece of code could be written better. It's because it interacts with your system in a way that the system doesn't really foresaw. And making a code smell go away usually isn't just, I will just rewrite those 5 lines. How could anyone have written them like this? It's quite often, I should also rewrite half of my system to get rid of this code smell. There's a C-squared wiki also page about code smell. A code smell is a hint that something has gone wrong somewhere in your code, so that's a little bit stronger. But also note that a code smell is a hint that something might be wrong, not a certainty. A perfectly good idiom may be considered a code smell because it's often misused or because there's a simpler alternative that works in most cases. Calling something a code smell is not an attack, it's simply a sign that a closer look is warranted. There's a second part to this, that there are 2 major approaches to programming. Pragmatic, code smells should be considered on a case-by-case basis, and a purist, all code smells should be avoided, no exceptions, and therefore a code smell is a hint of possible bad practice to a pragmatist, but a sure sign of bad practice to a purist. What I did when I first started learning about code smells is go through all of my pet projects that have 1 developer and 1 user and try to fix in a very purist way all of the code smells, and it taught me really, really well why you should actually take the pragmatist approach, because the code was super nicely refactored, it was very aesthetically pleasing, and it was totally unusable half a year later because I had to go back and figure out what the code was actually doing before I refactored it so nicely. So have a pragmatic approach, please. So how can we find code smells in our Ruby apps? You can actually do it by hand. You can just go through your code and pinpoint the code smells if you know what they look like. But you can actually use Reek. Reek is a tool that I'm one of the maintainers of, and it basically, it's a very opinionated static code analyzer that pinpoints your smells. You can think about it as a Robocop for architecture. So where Robocop checks your syntax and tells you that, obviously we all as a team agreed that 3 spaces are the best indentation technique, and we should, triple quote all of the strings, and we just put it in Robocop config, and now all of the code is automatically corrected to do this. Reek is like this, but for architecture, and it's also so much harder to, be very good at telling you this is wrong and you should fix it, because this is so much harder to say this particular code smell is really a problem. So you can just gem install Reek, and then Reek, for example, the conference RB class that we've been painstakingly building, and it will tell you that there are 8 warnings. There's a duplicate method call where the nav.info calls nav.source.info twice. There's a DataClamp where there are 3 methods that take this particular set of parameters that are always the same together. There's a repeated conditional smell where this is before the DataClamp refactoring, so that used to have check if, latitude, and longitude. And Reek is good enough to actually, track the AST of the if condition, so it can check whether this particular set of Boolean checks is being performed across your system. There's a predicate that has Boolean parameter strict. There's a control parameter, so this method not only takes a Boolean parameter, but it actually, this parameter controls this method. So the whole method is wrapped in an if-else and that checks this parameter. There's a successful predicate that refers to attendee more than self. This is the FeatureEnv, because we started to check the sum of the state of the conference, we check whether language is Ruby, but we mostly refer to the parameter. And this conference city is readable attribute, and this is probably the most controversial, is that the conference has no descriptive comment. Obviously, code comments are really, really a heated topic in programming, whether there should be code comments always, whether there should never be code comments. In an ideal world, your code would be, that's one side of this discussion. This is the other: war is peace, freedom is slavery, code is documentation. Like, it never is that easy. You never can write such a perfect code that wouldn't benefit here and there from some kind of comments. So, but also, if your particular class is so obviously named and has so obviously named methods, I'm perfectly fine with it not having comments. So how can you configure it? These are all defaults, but you can configure it really, really in a really detailed way that fits your project. You can say, for example, that DataClamp, by default, we say that if there are 2 copies of at least 2 parameters, then it's a DataClamp. So it's a very restrictive approach. But you can say, like, OK, I'm perfectly fine when there are 2, let's make it 3. So we can bump this number. We say that the method has too many parameters if it takes more than 3 parameters. But we have a caveat for constructors that usually tend to take more parameters than other methods, for example, for dependency injection. So we say that constructors can take 5 parameters by default, otherwise it's a smell. But you can reconfigure it for whatever. I have a project where a method takes, and it's an auto constructor, and it takes 21 parameters. And I need to refactor it, obviously, but there was a reason why it works that way. We have a too many instance variables smell that checks whether a class doesn't have too many instance variables. It used to be 10, and then we have a code that had 10 and decided that's obviously too many, so we kind of switched it to 4. 4 is probably too little, so you probably would want to kind of change this, but it's a restrictive default that you can update if you want to. And too many statements, we consider a method to have too many statements if it's longer than 5 statements, so it's a little bit more restrictive than Robocop default of 6, I think. But we, on the flip side, we exclude constructors because constructors, if they take 5 parameters and then painstakingly set instance variables to those parameters, because it's Ruby and not Crystal, where you can just do it in the signature. So yeah, so this is the thing. And obviously, one more thing, you can configure this on a project-wide method, but you can also say, I want to reconfigure Reek just for this class. But you can also say, I want to reconfigure this to all of the classes that match a given regular expression. So it's rather flexible, where you can say, all of the methods that start with a get should have this configuration. And obviously, first I can have too many methods in a class, then I can have too many code in a method. Sometimes gotta give people pick one. Having small objects with short descriptive methods is actually a good thing. And in general, in my experience, Ruby projects have too few classes. But again, don't go too far. Don't create a system where you have 200 classes that each has, nobody knows where the code lives. But actually, you can configure it not only in a .reek file, you can actually also configure it in code comments. And this is my preferred way to do it, because if you move a method around or rename it, this code comments will still work. So we can say that, I know this is a utility function, and I'm perfectly fine with it. Don't mark it as a smell anymore. Just say this Reek utility function, and it will never be considered it is a utility function, but we know that you're perfectly fine with it. Or for example, like this, you can actually reconfigure parameters of a different smell. So for example, you think that 2 calls are okay. In general, in your whole code base, you want to have a duplicate method called smell when there are 2 or more, but in this particular case, make it smelly only if somebody makes this call the 3rd time. So for the sake of this method, only consider a duplicate method call when there are more than 2 calls, not more than 1. And you can also have a per directory configuration. If you have ever written any or touched a Ruby Rails app, then you know the app helpers, I think, is the directory that has basically utility functions all over it. So, other than the process of moving from Ruby on Rails to software engineering, you can also just, for the time being, configure the directory of app helpers to just not consider those methods to be utility functions. And I'm talking about all of this because making Reek happy with my code taught me the most about OOP in the last few years. I'm super grateful for Reek existing in the first place, and also taught me a lot of how to parse, like becoming maintainer and having pull requests that actually introduce new smells and so on. This taught me a lot about how parsing works, how programming works, and I highly recommend, especially if you have your own small pet projects, using Reek on them, but always, always be critical of such tools. This is only a tool. It can only point you in the direction, and the fact that Reek doesn't like some of your code doesn't mean that the code is bad. It can be a really good, there can be very many reasons why it works like the way it works. There's a very good talk from Piotr, whom you will see also later today, that is called Clean Code Cowboy. And he said that correctness verified by tests comes before concerns about implementation details, and designing interfaces is more important than implementation details. So do consider whether your code is smelly or not, but only after you actually have tests that verify that your code works, and only after you have good interfaces between classes in your system, because those things are so much more important than the very subjective OOP-ness or code quality or not having smells in your code base. So those things definitely before that. And this is a wonderful quote, steps in mastery of a programming skill. Can I do this? Can I do this more easily? Can I do this more elegantly? Can I not do this? Like, eventually, maybe you will end up internalizing enough of code smells that you won't have to have this kind of tools. You will just, by default, write less smelly, better, easier to refactor code. So your world domination plans after this talk, please try out Reek. You can add it to Code Climate. If your project is on Code Climate, there's a checkbox that enables Reek. Don't be overwhelmed by the potential smells. So it's perfectly normal that you run Reek on your projects. You get like 5 screens of smells, and you basically never run Reek again. I mean, please don't do this. There is a Reek --to do. It's like Robocop's flag that creates the whitelist config file that whitelists all of your existing smells, and Reek will, from now on, only shout about new smells that you introduce into your code base. And then you can go into this .reek whitelist file and try to address those smells one by one, you know, fix them or actually flag them as perfectly fine. I gave this talk in Minsk last year, and there was a wonderful question at the end, like, does the Reek code base actually pass Reek? And that was one of my first questions. And it turns out, you know, we ran Reek on the Reek code base, and there were 5 screens of smells, of course. And it took us a month, I think, to basically fix 1/3 of those smells and whitelist the other 2/3-ish. But eventually, we do use Reek to refactor Reek itself. And please let us know what doesn't work. The worst thing that can happen from our point of view is you running Reek on your code base, getting really sad and not running it again. Like, please tell us if you think that the given code smell is configured too tightly, and the better default would be this. Ideally, of course, open pull requests. And please do have fun with refactoring and enlightened whitelisting. Please don't shy from whitelisting your code for code smells. This is, again, you know, more of a guidelines than actual rules of what should be done, what should be fixed, whether this is actually a problem or just something that doesn't look very OOP, but there's a reason for it. Thank you so much. I'm Chastel on the internet. Those slides for this are, as you saw in this particular instance, on this website. I work at the university. I also help run a consultancy where we do sometimes use Reek, so if you want your code to be better, we can help with that. And thank you so much, and if you have any questions, then you can also catch me later. I'm not sure whether there's any time after this.
Yes, thank you, Piotr. Questions?